Today we're going to be talking about the periodic table and how to use it to quickly determine the types of chemical bonds that you are working with. I mentioned this a little bit in my last video. Now I'm going to go into it in a little bit more detail, and I'm going to have you do some drawing on your periodic table. So the periodic table is broken up into two categories. So if you take yours out and take a look at it, we have this defining feature here, which looks like a staircase, and that's what it's called. I highlighted it in green. And the staircase separates the nonmetals from the metals. Now, you don't have to memorize that, but what you do need to do is understand that if you can identify just one of these elements in the corner over here, then you're going to know most of the periodic table, because let's do the exercise and it should make sense, hopefully. Oxygen, you're breathing it. Is it a metal? I hope everyone at home is saying, no, it's not a metal. I'm not a Terminator. I am not breathing in the metal, right? And so if oxygen's not a metal, then that means everything on this side, which isn't very large, but everything on this side is nonmetals. The opposite is true for the other side. They must be metals. Let's say you need a little proof. Take some metals that you know, like iron or copper, as in pennies, or nickels, as in nickels. And so these guys are all metals. Now, notice these ones on the bottom, they link to here, so they also fall into the metal category. And there is one exception, hydrogen. It's a non-metal. That's actually why hydrogen is spaced away from the rest of its group, and helium is spaced away for a different reason, but it's the same idea. Something about helium is different from the rest of this group. You should already know this one. These are noble gases. They all end in 8. Helium's a noble gas, but it ends in 2. So they spaced helium out to say something's different about it. They spaced hydrogen out to say there's something different about it. The thing that's different here is it's not a metal in a group of all metals. So just be aware of that one. But those are the basics of the periodic table. And if you noticed, most of the elements on the periodic table are in fact metals. And that means most of the elements in the universe are metals. Now, let's look at how they behave in terms of bonding. If you look at metals and you look at their valence electron number, we can start with K and just kind of go across. You look, you see one valence, then 2, then 2, then 2, then 2, then 1, 2, 2, 2, 2, 1, 2, 3. So if you notice and you look at all these, they're all going to be between 1 and 3 valence electrons. Well, what do elements with 3 or less valence electrons do in order to become stable? The answer is right there. They lose electrons. And so metals are the universal losers. They always lose electrons to become stable. And if you look at the nonmetals, they have 4, 5, 6, 7 valence electrons, and then the noble gases have 8, but we're going to ignore them. And so the nonmetals are all going to want to gain to become stable. So your nonmetals are your gainers, your metals are your losers, and the staircase doesn't really apply in terms of, the rules apply in terms of what they want to do to become stable, but what type of element, whether they resemble a metal or non-metal, is up for grabs depending on what they do. So that's why we're not really going to get much with them. We're really going to stick to solids, things that are definitely metals and things that are definitely not. So that is the basic idea. Metals, they're on the left of the staircase. Because they have 1, 2, and 3 valence electrons, they're always going to lose. They like to form positive ions, otherwise known as cations, when they become stable. Nonmetals do the opposite. They're on the right. They're always going to gain. The reason? 4 or more valence electrons, they tend to form negative ions called anions. Semimetals, or metalloids, they're on the staircase, have properties of both. The exception is alpha. And then I mentioned this before. The way you sum up the bond type is simple. When you're dealing with a metal-nonmetal, so a left side of the staircase and a right side of the staircase, that's going to be ionic. When you're dealing with two nonmetals, but they are not the same element, they are in fact different elements, you get polar covalent. So that means covalent means they are sharing their valence, but polar means because the sharing is unequal, there are positive and negative ends, otherwise known as poles. Non-metal, non-metal, same. That means you have two of the same element bonded together, like H2, F2, Cl2, those guys. That is when you're going to have non-polar covalent. So they are sharing their electrons and there are no poles. In other words, their sharing is perfectly equal. And then this is just a review of what you do in terms of the octet rule, and we talked about this. So this is just going to be a quick review, or this was just a quick review of what's on the periodic table, what the different types of elements want to do to become stable, and how to quickly identify the bond type.